In this session, we'll be working with the application of the NPV function, which is used in Excel with the help of a case-based situation. So we have taken the chemical industry part. Mostly, they also do the investment in manufacturing a particular chemical equipment. So we have a company, the assumed company is Chemical Equipments Manufacturer and Providers Private Limited. And you have the chemical component that they have to manufacture. Is they have taken the it's a policy document policy that they have the policies, and they have the projects in their hand, and the company is in the idea of whether to get into the project, whether it gives you the positive cash flow for them, and they are also going to do the cost benefit ratio. So we also find the cost benefit ratio for each individual chemical equipment. We do the net present value, and we'll be finding the cost benefit ratio, and we do the ranking for that. So so that we can make a quick decision and for the board of directors, so they can take the decision to invest in the particular equipment to be manufactured or not. So you have the chemical equipment given, the mixing tank, right? Mixing tank. Then you have the heat exchanger, then the chemical reactor vessel, hot air generator, then you have the centrifugal machine. Now the investments is in lakhs, right? So here we have the investment for mixing tank is 50,000 lakhs. So it comes in crores, right? So I just put 50,000, but everything is in lakhs. And the cash inflows I have just put it in the green, right? So green, as green, you assume it that we are just having the cash inflows, and red that I have just put it is like cash outflow, because we are doing the investment, right? So in similar way, for heat exchanger, you have the cash outflow 1 lakh, then the cash inflow is 50,000, which is a regular cash flow. It is not irregular, these are regular cash flows. Then you have the chemical reactor vessel investment of 1,20,000, and the cash inflow they are having is 30,000 for the period of 8 years. In similar way, for the chemical equipment for hot air generator, they have the investment of 1,50,000, and the regular cash inflow they are having 40,000 for a time period of 16 years. Then in similar way, we have the centrifugal machine, where the company is going to invest. These are the policy document that they have given. These are the expected values that they have created, right? So 2 lakh is the investment that they're going to make, and they're expecting that for the time period of 25 years they're going to generate a cash flow of 30,000. So we have to give the decision. So decision making will be done by the board of directors, but as an analyst we have to calculate the NPV, and we have to give the report to them, which could be the better way of putting their money into that and start doing the manufacturing of chemical equipments. So now we'll be working with the results now. So now the mixing tank, heat exchanger, chemical reactor vessel, hot air generator, centrifugal machine. So we'll be first calculating the NPV, then we'll be calculating the cost benefit ratio. And cost, we are not combining the project, just we have to check the individual chemical equipment which gives the higher rank. That could be done as the first preference to be given for investing in that particular project, that is particular chemical equipment to be manufactured, right? So first we'll be getting into the NPV. So apply the NPV function that we have earlier discussed in the earlier lectures. So NPV function for mixing tank, so we have calculate the NPV, so equal to NPV, right? And the rate of return that they have given is the cost of capital is your rate of return, minimum rate of return, or we call it as hurdle rate. So 10% is the minimum rate of return, so 10%, right? It is in cell G2, comma, and you have to select the cash flow for the cash inflows for the mixing tank. So we have the cash inflow from the cell C5 to C14, so I will be selecting this one, then close the bracket and minus the investment that they are going to make, right? So 50,000 is the investment. I enter it and enter. So you get the value of 60,602 is the positive NPV they are getting. In similar way, we calculate for the heat exchanger, equal to NPV then tab key, and the rate of return, the minimum rate of return is 10%, comma, and the cash inflows that we have to select is from the time period from 1st to 4th. So 50,000 is the selection that you have to make. Close the bracket, minus the outflow of the cash. The cash outflow is 1 lakh. So enter. So we'll be getting the NPV as positive, which is 58,493. In similar way, we go for the chemical reactor vessel, equal to NPV, tab key, and the rate is 10%, comma, and the cash inflow for this is 30,000, and the time period is 8 years. So I'll be selecting from cell G1, so cell G5, right, and close the bracket, minus the investment, which is nothing but 1,20,000. Enter. So you'll be getting the chemical reactor NPV comes positive, which is 40,047, and we have to calculate for two more, hot air generator and centrifugal. For hot air, equal to NPV, rate is 10%. We'll be doing relative reference, right? Then comma, then the hot air generator, you have the cash inflow, which is 40,000. I'll be selecting this entire 40,000 till the time period of 16 years. Then close the bracket, minus the investment that they have made is 1,50,000. So then I do the enter, you get the result as positive, which comes around 1,62,948 is the NPV for hot air generator. Then we have to calculate for the last, that is centrifugal machine, equal to NPV. Then rate, we have to do the relative reference, which is in cell G2, that is 10%, comma, then we have to select the cash inflow. In this case, we have the time period is for 25 years. So they are getting a regular cash flow for 25 years, which is 30,000. So I'll be selecting this one. Then close the bracket, minus, then the investment that is been made for this machine is 2 lakh. Then enter. So we'll see whether it comes negative or, so we're getting the positive NPV. 72,311 is the positive NPV for centrifugal machine. Then we have to, now we have calculated the net present value. Now we'll be calculating the cost benefit ratio, benefit cost ratio. So for benefit cost ratio, you have we have the formula for that, right? So BCR, benefit cost ratio, is equal to present value divided by your investment. Present value divided by your investment. So this is your formula for the BCR. Now we have to find the present value. So this is your net present value, but we have to find the present value, and investment value has been given. Investment, we have the investment of the value has been given. So here we have to calculate the present value. So I put it as PV, and we know what is the investment for individual chemical equipment, right? So I first put the investment value because we can reference that. So 50,000 for the mixing tank, 50,000 for mixing tank. Then for heat exchanger, we have 1 lakh. Then for chemical reactor vessel, 1,20,000. Then for hot air generator, we have the investment of 1,50,000. Then for centrifugal machine, we have investment of 2 lakh. So I put here 2 lakh, right? So investment amount has been put down here. Now we have to calculate the present value for the projects for mixing tank, the heat exchanger, chemical reactor vessel, hot air generator, and centrifugal machine. Then only we can able to calculate the BCR. Now present value, we can apply the PV function that we have discussed in earlier lectures, equal to view, we have to check out the PV function, then tab key. In this case, the rate, it will be asking the rate, right? So rate, I'll be selecting the rate as 10%, right? That is the 10%. Then NPR, it is asking the number of years. So number of years, You have to be very careful on selecting the number of years of this chemical equipment, right? Mixing tank. The time period is 10 years. So I will be putting 10 years. Then here we are getting the regular cash inflow, that is 18,000. So there is no future value, right? So don't get into future value, please don't do that. We have the PMT value given here, which is the regular cash inflow, or it's like annuity which the company is getting regularly for a period of 10 years, that is 18,000. So you can directly type 18,000, then close the bracket, and you'll be getting the present value. So here you find that it is giving you in a negative value. So instead of for calculating, if you do that, normally we will be getting the BCR in negative. For that, the answer is correct, but if we require in positive, here you can do here that minus 18,000 you can put, then press enter, then you find you will be getting the positive. So the present value for the mixing tank is 1,10,602. A similar way we'll be calculating for heat exchanger, equal to PV function, and the rate is 10%, comma, here the time period for heat exchanger is 4 years, so I'll be typing 4. Then the regular cash inflow that they are having, which is the annuity value that we are getting, is 50,000. So I'll be typing negative 50,000 so that we get the positive over there. So 50,000, and close the bracket and enter. So we'll be getting 1,58,493. And for chemical reactor vessel, equal to present value, tab key, rate is 10%, comma, the number of years that they have given is 8. Then the regular cash inflow for chemical reactor vessel is 30,000. I put it as minus 30,000. Then close the bracket and enter. So you will be getting 1,60,047. Then similar way for calculating the present value for hot air generator, equal to PV. The rate they have given here is 10%, comma, the number of year for the hot air generator is 40,000. So I can select 40,000, or right, so number of years is 16 years. Yeah, 16 years, number of years 16 years, 16, then 40,000, and close the bracket. So if you have difficulty in seeing these, you can get into the formula bar where you can see whether you're entering the value correctly, right? Then enter, we'll be getting the value 3,12,948 for the present value for hot air generator. Then we have for the centrifugal machine, equal to present value, the rate is 10%. So select the rate as 10%, comma, the number of years for centrifugal machine comes to 25 years. So I have to type 25, and the cash inflow that they are getting is 30,000, right? So minus 30,000 I'll be typing, then close the bracket and enter. So you'll be getting that the present value is 2,72,311.20. So 2,72,311. So this is the present value that you're getting. Now we can calculate the BCR. So we can type the BCR over here, and BCR formula is present value divided by investment. So equal to, go to cell D20, cell D20, right? So present value divided by your investment, which is E20, there is 50,000. Select it and enter. So you will be getting the BCR of 2.21, right? A similar way, rupee should not come. I'll put it as no specific format and reduce the decimal, keep it as 2 decimal point, 2.21. Then similar way, equal to PV, that is D22 divided by your 1 lakh, you'll be getting 1.58, and equal to again PV, present value of 1,60,047 divided by 1,20,000. Then you have for hot air generator, present value 3,12,948 divided by 1,50,000, then equal to 2,72,311 divided by the value which is in E28 for centrifugal machine. So I'll just change this format with no specific format and reduce the decimal to 2 places. right? So now you are getting the BCR, the benefit cost ratio. So this is your benefit cost ratio, and we have to do the ranking for that. So we'll do the ranking for the benefit cost ratio. Now there may be situations where policy member will say you have to combine the combination of the project, and you find the benefit cost ratio. That can also be done. And in this example we are taking only the individual part only, so we are not combining the equipments over here. We will be just calculating the ranking, give the ranking for individual equipment itself. Right now the ranking is the first rank that we can give. For first rank we have to give is, so we have to give the ranking over here, but I find that there is an outlier coming up, that is 13.62. so I have done some we have just missed any value over here. So investment is not 20,000, we have to check the investment value we have is 2 lakh rupees, right? So I'll change this to 2 lakh. Yes, now it is coming. So you have the BCR is 1.36. so while calculating you have to be very careful on seeing the outliers. Whenever you apply the function, there may be a inconsistency in typing the value. There may be a missing of zeros, maybe adding of some other instead of division you would have done the multiplication part, instead of division you have done multiple divisions. So you have to be a little bit careful on applying the function and do the cell references. So have a quick view of the outlier. So in this case we can do the ranking over here. The first rank that we can give to is the highest BCR, which is first rank given to this, and the second rank we can give for 2.09 for hot air generator. Then the third rank we can give for the heat exchanger, which comes 1.58, third rank. Then for fourth rank we go for centrifugal machine, and the fifth rank that we'll be giving for chemical reactor vessel. Now this is the report that we have to generate, and we do have to do the interpretation. As an analyst we have to do the interpretation, and we have to produce a report and prepare the report along with the model.